Let's now talk about propositional logic, which is an integral part of traditional logic, which help us to derive meanings from the truth conditions of various sentences. Propositional logic is also called propositional calculus or sentential calculus. It deals with the relationship between various sentences, which help us develop truth conditions, and especially the relationship between complex sentences. Irrespective of their internal structures, we could reach the meanings. We need to understand how they are built and what do they mean. For example, if we have two statements in front of us, John is in the office and John is at home. We can, from even commonsensical perspective, we can assume that only one of these can be correct at one time. Both cannot be correct. For example, if P is correct, which is the first argument, then Q is incorrect. And if Q is correct, then P is incorrect. So both cannot be correct simultaneously. And we can judge it from the very face of the arguments instead of getting deep into the structure of these arguments. So what makes us judge their truth value, their fact being true and false, are the conditions or commonsensical relations with the reality. So truth conditions are basically based on reality. They are not isolated from reality. The quality of sentences being true or false is roughly called as truth value of the sentences, which obviously lead us to know their meanings. And the conditions under which we could assume that something or some sentence is true or false is called truth conditions. And I repeat, we develop these conditions under certain realistic situations. Let's move forward with the presentation of this propositional logic in our semantics. We usually, instead of writing complete sentences to present a semantic model in this kind of logic, we use symbols. For example, for arguments and of various sentential variables, in other terms, we use the terms like P, Q, R instead of writing complete sentences. There are some other symbols which help us to describe various relationships between sentences. If the sentences are in a relationship of negation, for example, John is at home or John is not at home. So these two sentences are in a relationship of negation with each other. And we represent negation with a symbol in front of you. It's a straight line and then it sharply goes down slightly. So this is a symbol of not or negation. The next one is of conjunction, which we mean and. When we make a compound sentence by using and, it includes more information than a single sentence information. And this compound is shown by this symbol in front of you, or you could call it reverse V, the alphabet V. The symbol V is used for disjunction, which we mean inclusive or, which I have already explained in the previous module, which is either or relationship. Either one argument is true or the other. Both cannot be true simultaneously, right? So we have inclusive or, and we also have exclusive or, in which, and this is shown usually like this. We have a small e as a superscript here, and that shows exclusive or. That means either one of those can be correct. In inclusive or, we can see in certain conditions both arguments can be correct. I'll explain this further in the coming module also, but to sum it up simply, I can say that inclusive or is that either or condition in which in certain particular realistic situations probably both options can be acceptable, or one of those, if happens, can be acceptable, But in exclusive OR, we can see that only one has to happen. And if both happens, that would become incorrect. This straight arrow in front of you, this shows implication, and that in logic we mean if and then relation. If it rains, I'll go to movies. So this if then relation is the implication in logic. We have this symbol of equivalence in front of us, which shows the if and only if kind of relationship in logic. A simple linguistic effect on truth value or truth meaning of a sentence can be seen through various examples. I'll give you another example of the negation here. And negation is usually shown linguistically by adding the words like not in the sentences. Sentence A in front of you is that your car has been broken, and the sentence B is that your car has not been broken. In this example, if A is true, then B is obviously not true. So they are in a relationship of negation. To show this relationship in a logical presentation, we can see that it is P, which is A, the car has been broken, and then the second one is not P, right? These are not two entirely different sentences, logically speaking. Rather, the second one is the negation of the first one. So we have used the symbol of negation here, and then P. The first sentence is P, and second one is the negation of P. And this is how we present it in propositional logic. We can make a truth table for this, and in this truth table, we can use the symbols of T, alphabet T, and alphabet F. T stands for truth, and F stands for falsity. Have a quick look at the table in front of you. We have two options, P and not P. If P is true, then its negation is false. And if P is false, then its negation is true. So these are some of the simple ways how we describe propositional logic. There could be loads of other examples which can be cited here. And you can further consult it in your books.